Hello everyone. Today, previously we discussed about the topological sorting. Today we'll be discussing about the Euclidean algorithm. So this will be the final algorithm that we'll be discussing in this playlist. So next, I'll just take a long break from the YouTube, and after that, let's start doing the projects. Basically, I'm thinking of doing the projects on React Angular on the front end, and on the back end, we'll be making use of the Java Spring Boot as well as this one Node or the Express along with the databases, right? So this is what I thought of doing before hopping into the frameworks or the libraries or the frameworks. So mainly we'll be doing the projects on the JavaScript and the Java frameworks or the libraries. So till now we have discussed about the data structures and algorithms. Also we have done projects on this thing, vanilla JavaScript as well as the Java. So we have done some projects on this one in the Codeforces as well as the LeetCode, right? So this will be the last algorithm that we'll be discussing in the series. So let's continue with the Euclidean algorithm. So basically, let's discuss the approach step by step. So first step is where is Euclidean algorithm used? So Euclidean why and where Euclidean algorithm is used. So Euclidean algorithm is basically a method for finding the GCD of two numbers. So Euclidean algorithm, I'll just give EA. It is used to find the GCD of two numbers. GCD is nothing but greatest common divisor, right? So this is where we will be making use of the Euclidean algorithm. Next is, it is based on the principle that GCD of the two numbers, here this one, GCD of two numbers also divides their difference. So that's what it is, based on the principle GCD of the two numbers also divides their differences. So this is important thing. Just keep in mind this one. GCD of the two numbers also divides their difference. That is the principle of Euclidean algorithm. So what will be the process that is involved? The process involved here is replacing the large number with the remainder. So just give me a second here. Replacing large number, this one. We will replace this one with the remainder of the division of the two numbers. So we will replace the large number by the remainder of the division of two numbers. So I hope this step is very important. So I hope you just remember this one. So we'll be implementing the same thing in the code. So what we will do, the process will basically involve replacing the large number with the remainder of division of the two numbers. Repeating, so we will repeat this one until one of the number becomes 0. Repeat this one until one of the numbers becomes 0. Until one of the numbers becomes 0, we'll be repeating the same process. So the other number is, other number will be its GCD, right? So the other number, we'll repeat this until the one of the number is 0. Then the other number that we get is the GCD, nothing but the greatest common divisor. So I hope this is clear. So this is the approach that we are going with. So let's try to implement this one in the code, and let's try writing this one. I mean, let's understand this one with the example, and finally we will be discussing about the time complexity and the space complexity. So first, let me come here. I'll just write the function Euclidean algorithm. Let me consider the parameter C and D, right, for finding for the two numbers. So first what we will do, we will continue the loop until the second number becomes 0. That's what we had discussed in the this one, right? Approach, while discussing the approach. So let's continue the loop until the second number becomes 0. So I'll just make use of while this one here be not equal to 0, then what we will do, we will calculate the remainder of the division of A by B. So I can just write in this way, right? I'll just give here remainder equals A module B. So then finally we will update A to be the value of B. Nothing but here A equals B. And finally we will update B to be the calculated number. So I can just write here B equals remainder. So I hope this is clear. Finally, we have to return the non-zero value of A. Nothing but one number will be 0 and other number will be non-zero and it will be the GCD, right? As we had discussed in the approach. So that's what we have to return. Nothing but we are returning the non-zero value of A, which will be the GCD. So I'll just give here return A. This is it, right? So I hope this is clear. So let's consider example. After considering the example, let's speak about the time complexity and the space complexity. So I'll just paste this one example. So num1 and num2, two numbers, we have to find the GCD of the two numbers, right? I've just considered number 1 56 and num2 as 98. So here we are calling the Euclidean algorithm function, nothing but this one here of parameters num1 and num2. Finally, we are printing the GCD of num1 as num2 is nothing but GCD, right? So we have to get this one. So basically the answer has to be 14. Let's try running this code. So yeah, GCD of the 56 and 98, we are getting correct right here. We are displaying the GCD. So nothing but 14. So the answer is perfectly correct. So the answer is absolutely correct. Next, what we will do, we will discuss the time complexity and the space complexity. So what will be the overall time complexity? The overall time complexity would be big O of logarithmic minimum of A comma B. Why it is this one? What is A and B first of all? Where we know that A and B are the input numbers that we are taking here. This one, num1 and num2 we are considering here, right? This one. So logarithmic minimum of A and B. So this will be the overall time complexity. So what will be the overall space complexity? The overall space complexity would be big O of 1. So why? Because we are making use of the constant space and also only the few variables. Here you can clearly see in the code, right? So you can completely see the code. So the space complexity would be big O of 1. So yeah, I hope this is clear and this is it. Thanks for watching, guys.